Hi guys, welcome back to Classic Arcade Repairs. Pardon me. Darn. I just unboxed and unwrapped with a mountain of pink bubble wrap Star Wars board set. And this one, and this is huge. This is a big deal. I wanted to point this out. This customer sent along their harness, and this was not that hard to get this out. You know, it's not hard to get out. It's not hard to put back. But this is a big deal. This is an Atari Star Wars. These are absolute trash edge connectors. Your game will never be reliable with an edge connector like this. Never. So this is another thing to consider when you're working on a game or you're getting a game fixed. The edge connector, remember I always say connections are everything. This is garbage. Both of them. Look how pushed back that one is. And these, that one's burnt and pushed back on the end. Yeah, these are no good. This game, look at that one all burn up. These things are sideways and pushed back, and yeah. So this game would never be reliable with those edge connectors. So you get everything from turning it on to not having anything to do, or not the thing not working at all. Random resetting, freezing, stopping, burning the edges on the board. That's how edge connectors on boards get burnt, is because of this stuff right here. So, yeah. So we are replacing these edges. And this is out of a cockpit game, Star Wars. What was reported was it just random clicks with the coin counter, click, 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 click. It doesn't do anything, and then it stopped even doing that. So it's just dead. It doesn't do anything. Number one, that can cause that. This thing can cause all kinds of weirdness and the game not running. So this is imperative that this gets addressed. Always check your edges, your board connections in your games. So yep, and we have an Empire Strikes Back kit. I'm going to put that aside. I'm not even going to mess with that until this thing is running, until it's working as just Star Wars. Get that squared away, and then you can move on to the other stuff. So the two boards are up there, the main boards. Here's our interconnect board, I think. It's in there. And we have an AR and a soundboard. So I'm rebuilding and testing the AR, and then of course we're testing the whole board set. So yeah. So we'll get to it. I think the first thing I'm going to do is I am going to do the edge connector harness. Get that out of the way. So I'll do that and then come back with the boards. But this is just, elementary. It's just replacing the edges. That's all. So, and we'll get that done, and then we'll come back and start with the board repair. Yeah, one more thing about this is something kind of peculiar. I have never seen Atari use these. These are the kind of pins that destroyed Pac-Man boards. the kind of edges. These are the ones that you always saw on Pac-Man edge connectors. The solid pins like this. Yeah. I bet you this has hardly any tension at all going on the board. It probably slides right over that board. I'd be anxious. I'll be curious to look at the boards and see what the edges are looking like. Are our edges burnt up at all? That one looks great, so that's not a problem. And that one looks good too, so we're lucky. Although I don't think that AC is sent to this board, but 5 volts and ground can still, if enough resistance builds up between the 5-volt pin and ground on these, the AR will continuously kick up the raise the amperage or whatever, or to try to compensate for that. And that's how these things get burnt. So it doesn't matter if it's just, it doesn't really matter if it's not AC voltage. These could have still gotten burned up by those bad edges, but luckily they're not. They look great, so that's really good. But we need to take care of this before something bad does happen. So that's what we're going to do. Alright, I just got the Star Wars board set out on the bench, and this is a beautiful board set. It is the cleanest Atari board set I think I've ever seen. As far as nice and shiny and just beautiful. Clean. I got the harness done over here. Got my new edges. Nice, new. Nice and new and shaky, sorry. And I just encapsulated in a little bit of hot glue to keep it nice and safe. And labeled part side. Oops. Yeah, I'll just lay it down right here. That's fine. That's fine. Stay. Stay. There you go. Okay. Alright, I have ready to check some power voltages. Let's turn it on. I got it set up to here. It is now on and it's not doing anything. I hear some weird static out of the speaker. We have 5 volts here, which is good. That's right here. Move over right here. 5. Good. And then these voltages here. This is 5, 12, -5. Yeah. Voltages are all good. No problem. So, it's not doing anything. So I'll have to turn the scope on and start probing the CPU. Start probing around on the CPU and see where we're at from there. Let's put it in test. Will it give us anything? It is now in test. I'm going to restart it. We'll start it and test. No, it doesn't do anything. She dead. Yeah. Okay. These are all the right way. All right, so I can't get over how clean this board is. It looks brand new. It's awesome. All right, I'm just going to get the scope, turn the scope on, and probe around the CPU, probe some, basic stuff, and see if we're doing anything at all, if it's resetting, see what's going on with this thing. Make sure all of our clocks are at the CPU and that kind of stuff. Easy stuff. So I'll do that. I'll be right back. All right, I've been poking around a little bit, the CPU, and this thing is always in an interrupt state, so I'm kind of following the interrupt path. And of course it's taken me to decoding, so I need to find the decoding address decoders. IRQ clear. Here's what I'm looking for. So I've got the decoding portion of this thing out, and I can kind of fold this in half because this is what I need right here. Okay. All right. We have a LS138 at 8M. That's way up here. It's a decoding chip. Let's check it out. 1, 2, and 3 are its inputs, selecting inputs. It's way faster than what I've got my scope set at. Okay. Right. 1, 2, 3 all have signals going to it. And our 2 enables are 4 and 5, the other one's pulled high. So 4 is always high, which means it's never enabled. 4 is never enabling. 4 is out. 5, out S, outs. Where is that? Oh yeah, it's okay. Now we're moving on back because that's another LS138 has that signal on it at 2L, which is this guy right here. Those enables are connected, so 4 and 5 once again never enabled. Okay. Well, how about the 139 at 2J? Pin 1, never enabled. The 138 at 0BC is always enabled. Its inputs are 1, 2, and 3, and its outputs start at 15. This would be worth analyzing, this 138, because it's funny looking. It doesn't seem to have a whole lot going on for itself. It's got pin 7, or output 7, ROM 4, 2, 3, 4, I don't know. This might, I mean, it could be working exactly the way it's supposed to. You just never know these things. Yeah. Only one way to find out, guys. There is only one way to find out. And that is to analyze. Let's do it. My logic analyzer is wanting to go on the fritz. I'm going to have to replace the hard drive in it at some point, sometime soon, which is what I'm going to do. I am going to replace the hard drive in this guy and reformat it. I've got all my driver files and everything saved. So when that thing does die, I'll be ready. So let me go ahead and grab one of these. You know what else I'm going to do? I'm going to go grab a plug to plug in my camera so it doesn't die. Just kind of letting it run. Kind of letting it run so you guys can see in kind of real time what I'm thinking and what I'm doing. Alright, now there's no threat of the camera dying on us now. I'm going to turn the board set off. Okay. Grab this. Mow them down. Alright. We have our 3-bit select. 0, 1, 2. I do not need any enables hooked up because this thing is always enabled. Although, I have to see, do I have a 138 file? You know what I need to do? Let me go to System, let's go to Flexible Disk, and let's go to Load. And do I have a 138 on here? I don't think I do. I don't have 138 set up. So let's set up 138. We're going to modify label. We're going to call this an enable. And it's enabled okay. We're going to do this. The enable pins are G1, G2A, G2B. So it's a 3-bit enable, and it's got to be 100. So 100 is 4 in binary, right? 100. So we're going to say enable, clear. Enable, clear, en space 4. I'm just going to put enable 4. Modify. Enable, how about on 4? I put enable on 4, and that's 3 bits. So it's going to be G1, G, and I am going to hook it up. Even though I don't need it, I'm going to hook it up because that's the way I'm going to have to start doing this when I use these files. when I use the files that I create is I'm creating and saving logic analyzer files. So we got 3, 4, and 5. So it's pins 6, G2A is 4, and 5. That's G1, pin 6, G2A, pin 4, and G2B is pin 5. And whenever there's a binary 4 on those 3 inputs, that thing will be enabled. So that's how you trigger it. Okay. So now we need our output bits. And it's, well, I need to select is also 3 bits. So we got enable on 4, but I've got those backwards. Shit. Alright, I have to redo this. Okay. My first 3 bits are the enable, so bit 1 is pin 6. Bit 0, I mean. Bit 0 is pin 6. That is G1. Okay, and then G2A is pin 4, so bit 1 is pin 4, and then pin 5. That is my select. Now we got bit 3 is least significant select bit, which is pin 1. Bit 4 is pin 2. Bit 5 is pin 3. Okay, now that's correct. Now we have our 8 select output bits. So 8. There's 4 and 4 more. These are our 8 output bits, starting with bit 6. And that is pin 15. It goes 15 on down and then over to pin 7. 15 and bit 7. Okay, let's find number 8. It's right here. Number 9. Number 10. $11. 12. And then 13 is over on pin number 7. Okay, and we'll have our 8 output bits. Output. And that is 8 bits. So we're going to start how about right here? Perfect. Okay, and now we're going to go to listing and I'm going to hit binary for the output. We want the output bits in binary. Now go to back to format. Okay, and now I'm going to save this to my disk. So I'm going to go we're going to go system, flexible disk. We're going to store. I'm going to call it 138. And that is a 3 to 8 line decoder. 3 line to 8 line decoder. 3 line to 8 line decoder. Done. And we've got it. Flexible disk, store, 138, and execute. Now that file, I'll never have to create that again. It's created. And whenever you reload it, you just have to go to the format and find out what bit is what. No problem. Done. Go back to Logic Analyzer. Let's go to the trigger and clear out my trigger. Okay, I'm going to just put enable on 4 because it's always on 4, so it's always going to be enabled. Waveform, delete all. Let's do overlay, that, done, single, and let's turn it back on. How come this is never 4? Let's clear the trigger and see what's going on. It says always 1. Why is that? According to this, it's always... Oh, that's my least significant bit. Yeah, it always triggers on 1, not 4. So we're going to stop. I need to go back to format and put modify enable on 1. Enable on 1. Okay? Now we're going to go back to system. I'm going to overwrite this because I changed it, so I'm overwriting it and restoring it. You know what I need to do is I need to purge my old one and then redo it. The disk is full, so I need to purge this. Purge 138. Execute. I got another 138. I'm going to purge that as well. Okay. Now I'm going to go to store. Store Logic Analyzer. 138. And I have to redo this. 3 line to 8 line decoder. 3 line to 8 line decoder. And execute. Okay. I don't have to set the trigger on 1 because it's always 1. I mean, these are tied, the lowest bit is tied to high and the other 2 bits are tied low, so it's 0, 0, 1 all the time. There, now I got the new file, 138. So let's go to, back to Logic Analyzer, back to Waveform. Okay. Repetitive. Let's do the select. I want to mess with the select. Right here you can see it selects 0, 0 goes low. It selects I don't know if you can see that. I'm going to move the camera, give you a look at the scope. And this is how we look at this 138. Okay, you see where it hits, it selects 0. It enables on 1, which is, you know, most significant, 0, 0, 1. So here it's selecting 0 and the 0 bit goes low and the rest are high. That's how it's supposed to be. Here it selects 7, the 7 bit goes low, the rest are high. So that's good. But what I can do is I can manipulate the trigger, which clear the trigger. Always have to clear it. Yeah. So we're going to do a select on 1 and see if this thing selects 1. And it did right there. It was quick. I don't generally like doing that. I like a it's really kind of a glitch. That's just too fast, you know, to really accomplish anything. It's really just between 0 and 7. That's all it's really selecting here. But we can go and go back to trigger. Let's try 2. See if it triggers 2. And it never really triggers 2. Let's go back. I'm going to go back to 1. And it does 1 so fast. 20 nanoseconds. Is that really even? I mean, it's doing it. But that's so fast. You see a 0 there. It did select that 1 bit did go 0 there, but that I believe is probably just too fast. There's no way that can be designed that way. I think it's just like a glitch. But it is going low, and that means it is enabling this 139 that looked like it was never enabled. So that's something to remember, something to think about. 012, but it never enables 2, which 2 is what enables the 139 at 2J. 2. But this thing never selects 2. See, it never does 2. It is never trying to do 2. So it's not doing that. Okay. Well, let's see if we can trigger on 3. No triggers on 3. Okay. Let's try a trigger on 4. We're not going to do any, there's not going to be any triggering like this. This is only trying to trigger on 0 and 7, that's it. And it's working. See, 0 and 7. It's just going between 0 and 7. Yeah. So let's try 5. This is how you got to analyze, though. You got to analyze these this way. You have to try every scenario, because it might look like it's working to every scenario except for one. So you have to try everything. But so far this is working fine. It's really only selecting between 0 and 7. And even when it hits that select on 1 really super fast, it's still picking it up, and the 1 bit is going low. And let's continue. Let's try 6. And these are ROM bits, so this is probably, see, it kind of, it's selecting 6, but it's, oh. See, it is selecting 6, but 6 is not going low at all. But that is at 10 nanoseconds, which this thing, the access time might be within that. I don't really know. But the 6-bit is not going low. So that could be a problem. (20 nanoseconds, 50 nanosecond pulse. I would say that should be yeah, I don't know. It's definitely, the 6-bit is not going low right here. You can see right here where it's selecting 6. The 6-bit, the last one, you know, the second from the last one over this way should be a 0 right there, and it's not. See, it selects 7 and 7 goes low. But when it selects 6, that does not go low. That means it's not accessing a ROM. That is a ROM. So that could be our issue. So far I'm looking at 2 things. Number one, that really fast 1 when it would select 1, about the same as this. Actually, no, that doesn't matter, because that just goes into an LS08, which that's not the 139. So far, that 139 does not get any kind of enable at all. So just scratch that. Right now, this is the only anomaly I'm looking at, is this. So, I mean, is this a problem? That's an awfully fast, awfully fast pulse. Here it's sitting at 20 nanoseconds, which should be within the access time of these chips. Typically, I like to see things like this. This is at 500 nanoseconds with a nice pulse. Typically when you get down this fast on something, it can tend to be just a glitch. I don't know. But that's worth enough. And if I do this repetitive, I mean, it just nails that 6. But that does not go 0 at all. And when I nail 1, let's go back to trigger and do 1, right? And run that one repetitive. See how we're hitting 1 right here? And even if I back it off to where you can see this over here, see the 1 bit is a 0. So even though this is super fast, and that may be even like in glitch territory, it's still sending a 0. So I don't know. But this is stuck in a loop between 0 and 7, 0, 7, 0, 7. Which means it is trying to do some memory access and ROM number 4, which ROM number 4, it may be, I think that rests at a 0. I think that rests at 0, ROM 4, which is at bit 7. And it's sending it to 1 so that it can try to access something else. That might be where it's trying to access that other ROM, is when it's sending that high. Let's do this. Let's go back to the trigger. Let's trigger back on 6. Okay, let's do 1 shot and then zoom a little bit. So it did 0, which is a memory, trying to access some kind of a memory, and then 6, and I think that might be where it resets and goes back to 7. That could be the reset. When it doesn't access that ROM, it resets and goes back to 7 and rests. See, that last ROM rests at 0. So that could be what's going on here. It could be a bad 138 here. So, I mean, I think it's suspect enough to replace it. And then at least see if that, see if that does the same thing with a new one. I could even jump a 138 over it and see what happens. So I think I'll do that. So, yeah. Let me go ahead and stop the camera. Nice little kind of thinking through what's going on here and how to look at this. You can't just look at it like, a 07 looks good, yet what's going on in between there, and think about how Atari works. Atari works by resting that last ROM low, and it sends it high when it tries to access something else. And that might be what's going on here. So, all right, I'll be back. Let me I'm going to grab a 138 and just jump it over there and see what happens. Okay, I've got a 138 jumped over it and kind of got that 6-bit pulled up so that I can analyze it. This is the 6-bit on the chip that we analyzed. And you can see it just kind of does that. And this is the one that I got jumped over it. This is the 6-bit. You can see it kind of wants to dip down every now and again, but it doesn't go low, and I think that's what we're seeing. I think that was just so fast. I think it's kind of glitchy. I don't think it was meant to select 6. I think it's just too fast for this thing. So, yeah, I don't think that this 138 has anything to do with anything. So that's how you eliminate stuff. So we will keep looking. We're going to move on. So 6 is not being enabled at all. It's just kind of a coincidence where bits are changing so fast, and it just happens to stop on 6 for a minute. And you can see where it wants to go low, but it's just not. Before it even thinks about going low, it's back off of that bit. So, yep. Okay. Well, we will move on. Moving on. Let me put this 138 back up. Okay. And what are we going to do next? I really want to deal with this. 2 wasn't doing anything. I guess we should start at the very beginning. Let's look at address buffering. Probably be a good thing to do. So I need to go back to, let's start at the beginning. Start with the address, because addressing, address, all the software generated stuff starts with addressing. So ROMs tell something what address to go to and that kind of stuff. So I'll grab the microprocessor part of the schematic. 1B and 1C is what we're going to look at. These two guys right here are our address buffers. 4E is a 245. Data getting back could be funky, you know. Handful, there's a couple 245s here. Alright, so, well, let's start at the address buffers. Those are always enabled, so that is just simple to do. And we are on it, so that is simple to do. What I'm going to do is grab, let's turn that guy on. So we got two, and make sure they're set the same. They're not. No, they are. 2 and 2, 2 and 2, 500, 500. Good. So let me grab the 20 pin clip. And we'll just go in to out. The blue line will be our inputs, and the other will be our outputs. And 218. Alright, that looks good. Next. That one looks good. Next. Looking good. Looking good. Next. All right, looking good. Looking good. Looking good. Next. All right, next chip. That one is A-OK. So we'll move on to our next. Push that forward a little bit. Okay. All right, looks good. That looks good. Next. Next. Okay. Next. Next. That looks good. So our address buffers are fine. So let's move on to, I want to look at the data bus buffer 245 from the CPU to the system. That's 4E. So I'm going to go over and get on that. And that has, I don't care so much about the direction, but I do have to be on the enable, which means I have to, oh, let's just analyze this 244. stop, and let's go to system flexible disk, load. Oops. 245, load. Okay, now we go to logic analyzer format. Okay, that needs, I need both of my pods. So that will be both pods. But my first bit is the enable. That is pin 19. The second pin is direction. That is pin 1. Okay. And now we have our 8-bit A bus. 1, 2, 3, 4, 1, 2, 3, 4. Okay. The A bus is on the left hand side, so, and that's all the way down. A bus. Starting at pin 2. Let me set this up, I'll be right back. Okay, I have the 245 all set up, and right off the bat this is weird. It is never enabled. I'm triggering right now on enable being 0. I am on the enable, which is pin 0, which is my output 0. Trigger on 0, enable. Let's go to listing. This is all hex. That's good. Trigger 0. Let's just say that. It's never enabled. Huh. Yeah, enable is always high. Why do I have 2 enables? I have 2 enables. What's that all about? Let's go back to format. Why do I have 2 enables? And let's go back to waveform. Come here. Let's delete everything again. I tried to delete everything. Overlay, enable, direction, AB. There. Still, it's always still high. The enable is always 1. A bus is always FF. Direction is always high, which, whatever. 1, I think, is B to A. I think direction 1 is B to A. Yeah. I'm curious as to why this is never enabled. That is weird. So we go back to probably decoding. And what is this MB RAM, MB con signals? So let's look at the schematic. We know that 244, that is our data transceiver from the CPU to the system, is never high, or never enabled, I should say. So what enables that right here is these two signals, MB RAM and MB con. And R, not WB, is right there, and that is the read-write signal right off of pin 32. I'm just going to probe that really quick, sorry. Okay. Okay. Well, I guess we can look at those two signals. Let me find this MB RAM and MB con on the decoding. We'll find these two signals, and they go into a 08. You can see there. They go to 6K. So we can look at 6K pin 4 and 5 out to 6. I can do that really quick. 6K pins 4 and 5. Let's go to that, and let's delete this one. Done. And we can go ahead and look at 6K. And let's look back up to here. And we'll look at 6K. Pins 4 and 5 out to 6. Where is 6K? 6K. 4 is that. 4 and 5 is this. So it should be just high all the time. Okay. That's MB RAM and MB con. So where do those come from? Let's find out where those come from. Be right back. Well, you know what I did to just on a whim, I was like, you know what I need to do? I need to make sure that the CPU is not the problem. So I put in a new CPU. It's the CPU. It's a dead CPU. Believe that? How about that? And let's go back and look at our, now that we know it's working. Let's go back to the logic analyzer and run repetitive. And let's do the trigger on enable being 0. And let's come on, stop. All right. This whole period of time here it's enabled. Oh no, I was looking at the wrong thing. Here it's enabled and you have really? We need more of an enable than that. There we go. That's what we need. Do you need it to be something that's usable by the computer? It can't be so fast that it isn't going to matter. These things, you know, around 100 nanoseconds is about as fast as you want to go. I'm set at 200 right now. Really, I'd like to be right around 500 nanoseconds, but sometimes you got to zoom a little bit. See this enable right here? You have C7 and 8E. You know, that tells you that it's working. But yeah, it looks like it's perfect up there too. Let's throw this thing over to the Wells Gardner monitor. You wanna? The 6100. See what we got. Be right back. Looking good. I'll have to get my pots out and hook up to this so that I can test the gun and all that good stuff. So I will do that. I still have to rebuild the AR Ford, which I will do that. And test it. But first things first, let's what do we want to do first? Let's test the pots and the sounds. I know the voice works. Watch. I'll turn it off, turn it back on. And you'll hear Obi-Wan.
Force will be with you.
There you go. So let me dig out my pots and we'll test out sounds and all that good stuff. Alright, we're into the test menu and we can test the pots now. And you see they test just fine. Move it all over. And is this, yep. Left thumb, right thumb, left fire, right fire. Continue. No errors. Looks good. Looks good. Good. Oops. That's it. This thing works good. I am going to do some routine type stuff because does have these sockets, and they are a little bit corroded inside. So these sockets need to be replaced. So I'll do that. And of course, as I do with all of my vector games, with all of the vector stuff, we rebuild up here, because this stuff will fail. If this thing's running for any amount of time, these things can easily fail. So we're going to renew up here caps, amps, caps and amps, and then sockets. And that'll do. We've got the harness done, so this game will be nice. The AR is going to be done. I'm going to do this stuff first, and then I'll do the AR. So I'm going to do all of this work on this board. All of these sockets are getting replaced. All of these sockets. All of these sockets. And that'll do. We'll get to it. Alright, now I have this board stripped. I got the op amps all off, all 5 TL082 op amps off of it. I got the 2 regulators and then the caps off of it. And these sockets pulled. And we'll go ahead and repopulate this guy, and then I'll work on the CPU board. Alright, and here is the parts pulled for this. 140 pin socket, 7 24s. Here are the 5 8-pin sockets and new TL082 op amps. 22 microfarad caps, 100 microfarad caps, and the positive and negative 15 volt regulators. All new. So we'll go ahead and populate all of that into here. This board will be good to go. Okay, so we have replaced, I just got finished with this board. All of these sockets have been replaced. This one, this one, this one, this one, and this one. As well as clean the board. Clean the flux off of the back of it after my work. And I did the same thing here. This one, that one, these 6 sockets. And then rebuilt up here, new op amps, new sockets, the 5 op amps and sockets. The power supply regulators have been replaced, as well as the caps. These caps over here, all these, all good. And it is looking good. I will try to give it a quick playthrough and make sure everything looks like it's doing what it should. Alright, so we'll go ahead and do this. Alright. I guess I can just hit start.
Red 5 standing by.
And everything is good to go. All I need to do now is redo the AR board for this set. And this will be a complete system. The edge connector's been replaced. And we'll have a new AR. The owner can do a big blue. That'll have to be done, the big blue. And the board set will be solid for years to come. No connection issues. I will advise them to buy and have on hand an AVG chip, because it does have the original AVG chip. Yeah. Yep, it has the original AVG, which that's a ticking time bomb right there. So, arcade shop, Billtronics, there's a couple places where you can get these AVG chips, and you need a backup. If you have a color XY game that uses that, you need to have one of these backed up. So, because that will fail eventually. It will. It's just a matter of time. Alright. Well, I'm going to get to that AR. And I'm going to completely overhaul that thing. I'm going to replace the pins in the Molex plugs, everything. It's going to be, you know, made really nice. So this is going to be a sweet game. It should be reliable. Just have a couple parts in weight. One of those. It'll be good to go. I would say get a few RAM chips. Have some of these. You can just get 6116s. Have some of those backed up. Have an AVG chip in reserve. You'll be good to go. Anyway, I'm going to get to that AR board. And we'll be back. You know what I think I'm going to do? I'm just going to upload this. And then maybe I'll do the AR separate. Let's do that. Let's call this one good right here, and then the AR will be its own standalone repair. Alright. Thanks, guys. Thanks to all the Patreon supporters. Appreciate y'all. Thanks to everyone for viewing. Subscribe if you're not. All that regular stuff. And thanks a lot. Appreciate it. Peace out.